Okay, let us start. It's fine. So, okay, done. Okay. So today we are going to discuss about data cleaning. So previous we discussed about data collection. So today our focus is on data cleaning. So this slide is just a reminder like where we are. We are at data cleaning with pandas. We completed data collection, introduction to Python, and introduction to data science. Okay. So what is data cleaning? Data cleaning in simple is nothing but when you got the data sets in projects, you will get a data set. So what the first step you need to do before data cleaning, as we discussed, you need to understand the data set. What are the columns we have? What are the types of the column? What is the data type? And then you need to jump into data cleaning. So data cleaning in simple is nothing but removing the missing values, null values, and missing the inconsistency in the data. So after the data cleaning, the data set that you are dealing will be free from errors, free from missing values, and free from null values. And also data cleaning involves removing the duplicates. For example, if your data set contains any two rows like the same, if any two rows are similar, then they are called as duplicates and we need to remove them in order for the model building. And next, data cleaning also involves adding the data sets if you require. For example, if you got the data set, but if you think that I need more data set for further processing, so you need to search for the data sets and you need to merge so that it will be a single data set, and then you need to start processing and next the model building. So why we need to clean the data? Is it important to clean the data? Yes, it's very important because if you don't clean the data and you directly start giving the data to the model and start doing something, the model that you are going to build will not recognize the patterns that are in the data. So the model that you are building will not be accurate. So the reason for building the model is to predict something, right? So that purpose will not be satisfied if you don't clean the data. So these are the benefits of data cleaning. So if you've done the data cleaning, your data will be error free because you will check all the missing values, null values, and any inconsistency. And you will also check that whether your data is inaccurate or not, like whether your data is fake or is it coming from the direct source. And data quality, once you clean the data, the quality of the data will be good as you will do all the necessary steps that are required for the cleaning. And second, accuracy and efficiency. So once you clean the data and if you build any model with that data, definitely the model accuracy will be good compared to the data that you didn't clean. And complete data, like we discussed before, if we need any data that is required for the model building, we will search for the data sets from the source and we will merge the data. So then the data will be like complete data. Okay, next maintains data consistency. So these are all the benefits of the data cleaning. So the people just arrived. So here we are going to discuss about data cleaning, and we are discussing about the benefits of data cleaning. Like data cleaning in simple is nothing but removing the null values and the inconsistency, any duplicates, checking whether your data is accurate or not, is it fake or you are collecting from the direct source. So making your data perfect for further processing comes under data cleaning. So this is the cleaning cycle, and these are the steps in the data cleaning cycle. First, we import the data. In the projects, you will get the data set. So what is the first step you need to do? First, you need to understand what the data set is, like what are the columns, what are the meaning of each column. If you didn't understand the data sets, you can definitely reach out to us. Like, what does it mean? What does it is saying? Like, what is the type of this column? I am not understanding what this column means. So even though there seems to be like basic doubts, but those are very important when you are dealing with, the next step as data cleaning. So first you import the data, like you import the data. For example, we are going to discuss the model building in our Jupyter notebooks, right? So we will load the data sets into a data frame, which we will discuss in today's class. And next, we will merge the data sets. For example, as I said before, if you need any more data for further processing, so you will consider those data sets and you will merge it with the existing data. So it comes under merging data sets. And rebuild missing data. So you got the data set, and in the columns there are some missing values, like there are a lot of missing values, or there are only like 5 to 10 missing values. So you need to deal with that missing values. And next, standardize the data. Standardization and normalization, both are the two important statistical concepts which we gonna apply in any data science project. So these two concepts are really very important. So standardization, in simple, making your data uh, that is on a single scale. Like for example, you got a data set. In that, there are two columns. One is the salaries of the employees, and another column, the salary of the, for example, consider board members. So generally, the board member salary will be higher than the salary of the employees, right? So if you observe the values, for example, the employee may get like 30,000 per month. For example, the board person, let us consider he will get like 30 lakhs or 40 lakhs. So there is a difference. So you can't directly process it, uh, without any standardization. You can't directly consider those data. So first you need to standardize the data such that all values will be on the same scale. So it comes under the standardization. Then what is normalization? Um, Normalization is nothing but, if you see the distribution of the data, I think I have marked. Okay. I don't know whether I will draw correctly or not, but so this is actually a simple normal distribution curve. So whenever you draw the distributions of any data, you will get like different graphs. So this is the normal distribution, like a bell-shaped curve. So here, this line, so this line we call it as mean. So this is mean, so which is represented by mu. And here we have like sigma values. Like let us consider like sigma 1, sigma 2, and sigma 3. And here, here also like sigma 1, sigma 2, if you consider like negative values. Okay. So here, so this is the positive side, and this is the negative side of the data. So what does normalization means? So normalization, when you do your data normalized, so what does it mean? It mean like the mean value will be 0 and the standard deviation values will be 1. So whenever you do normalization, your entire data mean will be 0, so that the data will be like equally distributed, and the variance will be 1. What does the variance represents? Sigma is called like standard deviation. Um, if you consider sigma square, it is variance. So what does it mean? Variance basically explains like how your data spread from the mean. So these values will explain the spread of the data from the mean, and these values will explain the spread of the data on the negative side. So after you do normalization, you will get the mean value as 0 and the standard deviation as 1. And next, deduplicate. It is simple, in simple, that you are removing the duplicates. For example, if you consider the data set and there are 3 rows which are exactly same. So what you will do? You will remove that. There are duplicates, so you will remove two rows, and you will keep only one row. And verify and enrich, yes. So as we discussed before, you need to verify the data. Like simply considering what is there in the Excel sheet, it's not a good practice. You need to verify whether this is accurate or not, whether this is valid or not. So that comes under verify. What is enrich? Enrich is nothing but like enriching your data set. For example, if you think that uh, like there are 10 columns in your data set, but if you think that adding one more column will enhance your data set so that your model will predict the values accurately, or you think that I can build a model most accurately, so then you can add that one more column. So that comes under enriching. And export data, so once it's done, like you done everything like cleaning and missing values, null values, inconsistencies, you deal with everything, then you will export that data to the model. Okay, so model building is very easy if you know the code. uh, it is very easy. You can simply ask the chat gpt, it will give the code and you can just copy the code. But the thing, in order to data cleaning, we should have knowledge, we should know some statistical concepts, then only we can clean the data very well. Next, so in data cleaning, it's very important to know about Panda, as we discussed in, I think, second lecture. Pandas is a powerful tool. It provides all the libraries that are required for the data cleaning. So whatever the methods and the libraries that you required, Pandas will provide everything. So it's very important to know about Pandas. It simplifies working with structured data. Pandas, it is very easy to work with the structured data. The data sets that you are getting for the projects, they are the structured data sets. You can simply use those data sets into a data frame and you can start data clean. So in Pandas, the main concept is data frame. I will show you how a data frame will look. One second. Mm, okay. So this is simply a data frame. Here, if you observe name, age, allies, like these are the values. So this is how a simple data frame will look. And these are the rows, and name and age are the columns. So this is how a data frame will look. In your projects, you will do one step as this is the starting step. So this is the file. You will directly load this file into a data frame. So why we load the data, like the CSV file into the data frame? Can't we operate all the operations directly on the CSV file? Because it is also the structured data, right? So why it is necessary to load into a data frame? Because on data frame, Pandas provides many libraries so that you can work easily on the data frame instead of working directly on the Excel sheet, on the CSV sheet. It is very easy to work on the data frame. Next, okay. So rows, column, and index. So here are the 0 and 1. So here, if you observe this 0, 1, 2, 3, 4, so these are the indexes, and these are the rows, and these are the columns. So don't get confused. Like in midterms, everyone will get confused on the indexes. So basically, they don't know like where the index will start. So always remember the index will start at 0. Okay. Key reasons to use pandas. As we discussed, pandas provide the various libraries and methods that are required for the data cleaning. There are mainly two primary data structures the pandas provide. One is data frame, which we are discussing now. It's a two-dimensional table-like structure, similar to an Excel spreadsheet. So if you observe a data frame, it simply seems to be like a table. It has rows, it has columns, and it has indexes. And there is another structure that pandas will provide, that is series. So series is basically a one-dimensional structure. So if you want to store only a single row, a single column, then you will prefer series. But if you want to store the entire rows and columns of an Excel sheet, then you will use data frame. And what are some of the methods that we apply on our data set? So if you want to handle the missing data, you will apply the two methods. One is fill NA. Fill NA is nothing but you are filling the null values. NA represents what? The null values. And drop NA. For suppose if there is a column in your data set, like most of the like values are missing. For example, like 80% of the values in that column, they are missing. So you can simply drop that column, because even you can't fill the 80% of the data. You can fill like 5 to 2% or like 3 to 5% of the data, but you can't fill the entire data, right? So you can simply ignore it. So if there is 80% of data that is missing, so simply you need to drop. And you can drop that by using drop NA, or if there is only 2 to 3% missing, you can fill with some values. We will discuss further with the help of fill NA. And next, removing duplicates. So if there are like any three rows, the same rows, we can remove that. Like we can drop the duplicates by using drop duplicates method. And standardize and correcting data types. For example, if you need a particular like column data type as int, for example, if you need the salary as float, and for some members they need like as int, so you can convert the data type based on your requirement by using as type. And next, replacing, renaming, or transforming data values. So if you want your column names to be replaced, like you think that this is not a proper column name for this data, you can simply replace it. And renaming, yeah, you can rename it to make it more useful. Okay. And transforming data values, like we discussed, like if you want to transform it from int to float, like whatever you want, you can do it based on the requirement by using as type. And to date time, for example, in your data set, if there is a column, and in that column they mentioned like year, month, and date. And some of the columns they mentioned month, year, and date. So you need everything to be in a single format, right? You can't deal with 2 to 3 formats. So by using to date time, you will get a particular format, that is year, I think month, date, and if there is any time like hour, minutes, and seconds. So in order to get a single format, you will use to date time. Okay. And the third reason for using pandas is efficient data manipulation. So as we are doing a lot of changes to our data set, so it comes under data manipulation. So pandas provides all the tools that are required. So without pandas, you can't do data cleaning. Okay. And index and slicing. Index and slicing, I will explain you with an example. Okay. So here, okay. So here, if you observe, there are two things. One is a lock. I applied df.lock. Like in simple, I loaded the pandas. I consider a single list, which I consider it as a data, and I loaded the data in a data frame, like pd dot data frame into data. This is the basic line you will use everywhere to load the data into a data frame. And here I applied df.lock 0 to 2. The 0 to 2, the part 0 to 2 is called a slice. Okay. Like slice is nothing but a piece. If you cut an apple, like each one is a slice, right? So here in the entire list, 1, 2, 3, 4, we are considering only 0 to 2, which means like 0, 1. So in the data, it is 1, 2. So we are considering only a slice. Then what is meant by lock? Lock basically, it will, when you apply lock on a data frame, so it will also include the last value. So basically 0, 2 should give 1 and 2, like this here. But as you applied lock, it is giving the third value. So the third value is also including. So we all know that the range 0 to 6, basically in coding, it only gives from 0 to 5, right? Only 5 elements. It will exclude the last element. But when you apply lock, the last element also included. That is the reason you are getting 3. And what is ilock? In ilock, the last element will be excluded. So you will get only 1, 2. So the 3 we won't get when you apply ilock. So these are two, slicing and indexing in data frame. Next, and filtering. Filtering is nothing but applying a condition to a column. uh, there is a data set and there is a column which explains all the salaries of the employee. But you need like the employees whose salary is only greater than 30,000. That's all. You don't need the rest of the data. So what you will do? So here, if you observe the example, in the data frame, you will keep the column name as employee salary, and you will give the condition greater than 30,000. So if you apply this on your data frame, you will get the data with the employees only whose salary is greater than 30,000. That's all. The rest will be like you won't get that. Aggregation. Aggregation is nothing but basically we used group by in SQL too, right? If you want to group the members based on their initial name. For example, you got an Excel sheet and you want to group the members based on the initial name. So you can use group by, and in the parentheses, you can mention initial name. Or if you want to group the entire column based on the first name, so you can mention group by in the parentheses like first name. So group by is used to group the data based on the condition that you require. Next. Okay. Powerful data transformation. Pandas is useful to merge or join data sets. As we discussed before, you got the data sets and you think that it's not the proper data and you require like more data to process. So then you can use merge or join methods to do that. Like if you have two data sets, you can simply apply merge and join methods. And this concatenation is nothing but like adding. If you want to add anything vertically or horizontally, you can use this method. And you can reshape the data by using pivot tables, melt, stack, and unstack. So I give the code here. I think, see, this is using the pivot table. So here I consider the data, like data is called employee, product, and sales. And here I loaded the data into a data frame that is DF. And here, if you observe, yeah. So if you observe, like I consider that the index, columns, and values, and I use the aggregation function as sum. So this is the output that I got. And here I use like, so this is the melted function. Yeah, I applied the melt function. So melt is basically used to convert the data like from wide to long. Okay. And okay. So here, if you observe, after applying this pivot df dot reset index, so here it seems to be somewhat different. Like we are getting all the laptops as one group and all the phones as one group. But in a simple data frame, you will get like this, like laptops and next phones. But here, as we applied this pivot, we will get, this is the output that we will get after applying. So this is the output that we will get. And let's move to next, that is the stack. So we applied stack method on this. So stack is basically used to convert columns into multi-index row structure. So here we have like multi-indexing. And unstack is basically used just to reverse. It means just to get the original data frame. So this is the original data frame. Okay. So high performance data processing. Um, Basically, in any data processing, if you want to deal with mathematical computation, so we generally use NumPy. So Pandas is built on NumPy. So Pandas also supports the numerical and mathematical operations, and that is the reason by using Pandas you can process very large data sets. You can simply read any data sets like within a few seconds. Okay. Integration with other libraries. Basically, if you want to do data visualization, we will use two libraries. One is Matplotlib and Seaborn. And for machine learning, like for if you want to do model building, you can use scikit-learn and TensorFlow. So pandas can be used with all these libraries. So if you want to do the visualization, you require pandas. If you want to do model building, you require pandas. So pandas is like a basic step for the entire model building and also the processing. And before I showed one example, right, loading the CSV file into a data frame. So it comes under the data storage. So we are simply storing the entire file in a data frame. And flexible data input and output, yes. Instead of operating directly on the Excel sheet or CSV sheet, like we are completely loading the entire data sets in a data frame and we are performing the operation. So it is simple, very simple to operate with data frames compared to doing operations on the original data set. And key reasons to use pandas, and there is one more, handling missing and inconsistent data. So if there are any missing values, first you need to check, right, because you can't go entire column like column wise to check the miss values. So you need a simple method to check how many missing values are there in your column or in your data. So is null is a method that you apply on the data frame to get all the null values in a column. And fill NA, as we discussed before, if there is only like 1 to 2% of the data is missing, and you can fill that, like that values with the fill NA option. But there are some steps you need to take care before filling any missing data, because the data is missing. And while filling that data, like there are some steps, like some prefer like filling the data with the mean value of the column. So you consider a column and you find out the mean of that column, and that mean values will get, the empty values will get replaced by the mean values. And some members prefer to keep all the zeros on the missing values. So based on the data that we are dealing, we need to think which method is perfect to fill the missing values. And we always need to make sure while filling any missing values, we can't simply type any value on at the missing place and we say that, okay, my data is filled, like I already filled the data. No, you need to take care while filling the missing data. And next, standardize. Yeah, I already said the standardization and normalization is very important. So you need to standardize and normalize the data. And this is the link. So if you want to learn more about the data cleaning using NumPy pandas, you can visit that link. So this is how a simple pandas will look. You will import pandas by using import pandas as PD. You will load the CSV file. Sorry. And you will filter rows where the column age greater than 30. As we discussed before, if you want any employee salary greater than 30,000, you will use such kind of conditions. And calculate the average value of your column. So in your data set, for example, in your column, there are only like 2 to 3 missing values. So you can opt the option of filling those missing values with the mean. And by using that mean method, you can calculate the mean of a column. So here we are calculating df salary dot mean. So simply we are applying the mean method on the salary column so that you will get a specific value, and that value can be used to replace the missing values in that column. If there are only like 2 to 3%. Okay. Now, what is data frame? So data frame is a two-dimensional structure. As we discussed before, it contains rows, columns, and index. The rows represents the individual records. So there is another name for the rows, which is called like records. The rows are also called as records. And columns, um, they are also called as attributes. Okay. And next, key features of your data frame: heterogeneous data. So in your data set, if you see the columns, there are of different types, right? There are strings, there are int, float, and there are many more. And indexing, the rows and columns are indexed. In before I showed a data frame, and there are index values. And label data, both rows and columns will have labels in a data frame. And flexibility, with data frame, it's very easy to deal. like we can filter what we want. We can simply handle the missing values. We can simply handle the null values, and we can aggregate the data and we can merge the data. So this all we already discussed. Creating a data frame. So here we consider the data like ID, name, age, city, and salary. So these all concepts, you just listen, know what is what, and you can, like if you want to practice, you can practice after going to home, or you can just leave it. It's fine. And I loaded the data in a data frame, like pd.data frame data, and I just printed the data frame. So when I print the data frame, so this is the output. So this is the output of a data frame. It contains the rows, it contains the columns and the indexes like 0, 1, 2, 3, 4. And make sure the index will start at 0. Okay, it not start at 1. Creating a data frame. There are several ways to create a data frame. So before we discuss, so this is like one of the way, right? I gave the data as a list. Like this is the dictionaries because we have key value pairs. So this is one of the way to create a data frame. But there are several ways of creating a data frame. We can create the data frame from the list. We can create the data frame from the series and dictionaries and list. Like there are several ways. Let us discuss one by one. Here I consider data equal to, this is basically a dictionary. Name, age, those are the keys, and Alice, Bob, and next 25, 30, those are the values. If you observe, the values are in a list. So this simply explains creating the data frame from the list. Dictionary of series. So series is basically a one-time instance structure, which is basically used to store only a single row or a single column. This is the example. I considered the data name, and here I consider the series like pd.series Alice Bob and the index as 0, 1. And next age, for the age, I considered pd.series 25, 30. So this is similar to the previous one, but here we consider like series, pd.series. So from the dictionary of series, we can create the data frames. And from the dictionary of dictionaries, we can create the data frame. Like if you observe the example, like we are considering dictionaries in a dictionary. With that, also we can create a data frame. From the list, by using the list, also we can create the data frame. This is one of the examples. Here we consider the list in a list, and we created the data frame by using this. And list of dictionaries. Here we consider the list, and in the list we have dictionaries. So with that, we created a data frame. I will show these all examples in the Python file. So let me show that code here. Yeah. See, here we are creating the data frame from dictionaries. So here I consider the dictionary name, age, like key value pairs, and I gave the data in that data frame and I try to print the data frame. So this is the output that I got. Okay, and here this is creating data frame from dictionaries of series. So this is a dictionary, and here I consider that series only like a single column, and this is the output that I got. And here I am creating data from dictionaries of dictionaries. So this is a dictionary, and inside there is another dictionary, and I created the data frame by using this. So this is how I got. So see, if you observe like row 1, row 2, those comes under the indexes, and this is like the simpler, the basic one. And here, this is creating the data frame from list. So here I consider two lists. So one is the names and age, and another is the name and age. And I loaded that in a data frame, and I printed the data frame. So here I have the indexes as 0, 1. So if you observe here, we have the indexes as row 1 and row 2. So based on the type of data that we are considering, like the output will be different. Next, yes, creating data frame from a NumPy. Let's go back to the slide. So we can also create the data frame from NumPy array. Like if you want to use NumPy, we need to import NumPy as NP. And here I consider the array. And next I loaded this I consider as a data, and I simply loaded this into a data frame like data, and I gave the columns like A, B, C, and I printed the data frame. Let's see how the output. So the same example that we discussed in the slides. So here I loaded the NumPy and I considered the array. And here I gave the entire thing in a data frame and I try to print. So see, this is the output. Here I mentioned the columns as A, B, C. So here I got A, B, C, and the 0 and 1 are the indexes, and this 1, 2, 3, 4, 5, 6 are the values. So whatever you keep in this np dot array, it will be the row values, and here these are the column name. Okay, from a CSV or Excel file. So we simply load the file, like whether it can be CSV. If it is CSV, we use CSV here. If it is Excel, we will use Excel like EXEL, and we will print that data frame. Yeah, so this is the Excel sheet. So this is creating a data frame from the CSV file. So here I consider the iris. I loaded the iris file in a data frame, and this is the output that I got. So this is how a data frame will look. And this is, I think I didn't show the Excel sheet, but it will be the mostly same. From existing data frames, so you can also create the data frames from the existing one. So this will be useful if you want to divide your data sets into parts. For example, um, like at one step of the model building, you may require only few columns, but you don't require the entire data frame, right? Like the entire Excel sheet. So what you will do, you will create a copy and you will try to save it, and so that you can use it at whatever step you need. So this will be like this you can understand when you are doing the model building. And subset of your data frame. So if you want to load, like if you require only like two columns from the entire data frame, so you can use this subset. Like you can consider only two columns. So if you observe, I considered only like name and age in a data frame. From your panda series, you can create a data frame from panda series. So here S1 PD dot series 1, 2, 3, and this is the column name, and this is the second series. The column name is B, and you are using the concat. So previous we discussed about concatenation. So we are adding the two series here by using this method. So this is one of the way of creating data frames from series. Let's see whether we have code here. Existing data frames. See, I just copied this df.copy, and I just copied this in another data frame. So here from the subset, see, this is the entire data frame, but here I consider only two columns, sepal length and sepal width. That's all. So when you want to deal only with two or three columns, you can use this subset method. And this is from the panda series. Just now we discussed. So this is S1, so creating the first series, and this is S2, creating the second series. And I am adding two series. So this is the output that I get from this panda series. So if you want to create the data frames from databases, so you can use this code. Simply like pd.read SQL as we are dealing with databases. So you will write the code, like select from table name and the thing that you want. So this is one of the way of creating data frames from SQL, like by using SQL command. From scalar values, you can create a data frame by using scalar values. They specify the shape. So if you see the example, I considered like 5 and index range 3 and column names A and B. Let us see this with the code so that you will understand better. So here, yeah, this is creating a data frame from scalar value. So here I consider like pd dot data frame. See, I did not loaded any data before. I just considered the scalar values is nothing but a value. So 5, and I told that like index equal to range 3 and the column values A and B. So here I got the column values A and B, and these are the indexes like 0, 1, 2, and I said like range 3, so like 5, 5, 5, 5, and 5, 5. Because I gave only a single value 5, I got the values as 5. If you give 2, you will get like 2, 2, 2, 2, and 2, 2. So this is creating the data frame from scalar values without using any, like any CSV or Excel sheet. And next, from a zip object, you can create the data frames from zip object. So I consider data equal to zip the names and the values like age, and this is the codes. And this here I loaded it into a data frame and I try to print the data frame. From NumPy, CSV, we only dealing with CSV files mostly. So these are it is good to know this because you may require to create the data frames from the scalar values, like from NumPys. So it's good to know this information. So here from the zip object, just we discussed. So here I consider the zip Alice Bob and the age. So here I gave this data in a data frame and the column values name age. And this is the output that I got. It simply looks like a data frame. And creating data frame from multi-index. Go back to slides. Yeah. We can create the data frames by using multi-index. So this is the code. I will explain directly from the file. So this is creating a data frame from multi-index. So here I considered pd dot multi-index from tuples. So here this is how tuples will represent, right? So here I considered a list of like in a list I considered the tuples, and here I considered the data and I loaded the data in a data frame and the column values as value 1, and here I printed the data frame. So this is how you get the data frame from a multi-index. So like group 1, yeah, this is like group 1, A 1, 2, and B 3, 4. Like group 2, A 5, 6, as we gave only this value. Next. Mm, Okay, series. So till now we discussed a lot about data frame. And now we'll move to another type of data structure that pandas provide, that is series. Series is basically a one-dimensional structure. It will take only a single column or single row, and it can hold any data type. We can store any integers, floats, or strings in a series. And it is the fundamental building block of pandas data frame. Because in a data frame, if you consider like only a single row or a single column, it comes under the series. And key features of a series. So labeled index, like each element in a series is associated with an index. So every element in the series, for that we have an index. And by default, the index starts from 0, but it can be customized. Yeah, you can customize the index, but generally it will start from 0. So this is how a series will look. Um, this is the code, like import pandas as PD. I considered the series. So as I said, it's only a single row or a column. So I considered the column values 10, 20, 30, and I gave the index ABC. If you observe here, I gave the index, like particularly I gave the index. If I didn't give the index, I will get 0, 1, 2 instead of ABC. Features of pandas series. Yeah, here, if you observe, I gave the index ABC, so that is the reason I am getting ABC. But if you didn't mention the index here, you will get like this, like 0, 1, 2. So that default index will appear if you didn't give the index particular. Next, let's go here. Homogeneous data, the series can also store the data of same type, like it can store the entire integers. Previous we discussed about 10, 20, 30, so it comes under the integers and floats, strings, but you can also mix the data types. So if you see the code, I consider like three data types. One is 1 and 2.5 float, like integer, like string is hello. So here I consider three data types and I try to store it in a series. So yeah, it worked because series can handle like different data types. So here it supports various data types. Here, if you consider, I consider A10, B20, and C30. So this is how a series will look. And next we'll go to slides. It seems to be a boring stuff, but it's fine. You can just simply listen and know the concept. Okay, it will be useful if you want to do any further projects in depth. And series supports various data frames, which we already discussed now. So here, if you observe, I consider the dictionary. So here, this A, B, C, these are key value pairs. So this is a dictionary. So series supports like various data types. And this is the output that I get if I execute this code. Vectorized operations. So similar to NumPy arrays, operations on series are vectorized, which means you can apply mathematical and logical operations. So if you want to apply any mathematical operations, you can do that. Let's jump into the code. Yeah. So here, if you observe vectorized operations, so here I consider the series as 1, 2, 3, and I try to multiply by 2. So you can directly do the operations at the place. You can simply multiply, or if you want to add, you can do that. So I multiplied by 2. So that is the reason I'm getting 2, 4, and 6. And alignment by index. So if you here I consider like two series, S1 as PD dot series 1, 2, 3, and I gave the index particularly. So the A, B, C. And I considered the second series and I gave the index. So I try to add both series, and this is the output that I get. Okay. So here missing handling data. So series also useful to like handling missing data. So here I consider like 1, none, and 3. And see if you observe the output here, we got none. So whatever, if you didn't mention any values in your data, it will be taken as none. Okay. And so in your data sets, you will see these values. So definitely you will see these values in some of the columns. So remember that the NaN means like the data is nothing. So like there is no data in that. And sliceable and indexable. So here we consider the series and the index. I try to print S of B. So here I got 20 because B has 20, right? And here S of 1, it will access by position. So it will get the 20. So here I'm trying to print the values by using the like label. And here I'm trying to print the values by using the position. Okay, so here the actual part starts like cleaning the data. So let's see, are there any slides? Series is done. Like I explained all the concepts. Adding a column to a data frame. So you have your data frame, but you need to add one more column. So you can do that in several ways. You can add a column with a fixed value. So if you observe the code, uh, I consider a data frame like name with the help of dictionaries like name and age, and the values are Alice Bob 25, 30. And I try to add like DF country equal to USA. So I'm trying to add a constant value to the new column. So you can do that by using data frame. See here, Before that, see, at initial, I gave only like two names, like name and age. But later, I try to add one more name, that is country name, USA. So after adding a column name, this is the output that I get, like country USA, USA. So it will replace all the country column as USA, USA. Okay, can do that. And deleting column from your data frame. So if you don't want any column from your data frame, you can delete it. There are several methods in cleaning it. One is the del, and one is the drop method, and one is the pop method by using lock and ilock, and using the column reassignment. If you delete a column from your data frame by using a delete statement, it will completely remove that column from your like data frame. So once you delete it, you can't get it back. By using the drop method, you can simply drop a single column or a multiple column. But by using pop method, you can still delete it, but it still exists. So if you want to regain that column name again, you can use the pop method. And you can replace the columns if you want by using column reassignment. Like, see, if you observe here, I deleted a column by using L. I consider a data frame, and here I am deleting the country. So that is the reason, if you observe the output, there is no column country. Next, by using pop method, yeah, by using pop method too, you can delete. So you will get a data frame without country. Row deletion. So you can delete a row if you want in your data frame by using drop method. Boolean masking. Boolean masking is simply nothing but filtering. So before we discussed, like we gave the condition to get all the employee salaries greater than 30,000. So that comes under Boolean masking. And ilock, we already discussed this index-based selection. So row deletion, the drop method allows you to remove rows by their index. So this is the code. I imported pandas and I considered the data frame. And here I use like df dot drop index equal to 1. If you mention index equal to 1, it will delete the row with index 1. So that is the reason you will get only 0, 2 in the output. The 1 is missing because you mentioned specially that index equal to 1. So you deleted that, like you dropped that row. Row deletion, you can also do the row deletion by using this Boolean masking. Um, as we discussed before, I'm giving the condition like df age greater than 25. So which means I only want the value whose age is greater than 25. I don't want the rest. So that is the reason I'm getting output with the values 30, 35 for the age. So whose values are greater than 30, those rows we will get. So Boolean masking is nothing but giving a condition that you want. Row deletion, so we can use ilock. That is a code to remove the first row by using the ilock. df dot ilock 1 to like, so it starts like we are giving that, as you mentioned 1, it shows that you need to remove the first row. That is row 0. So first row means row 0. And adding new rows using append. Append is simple, like appear at the end. So here I consider two data frames. Uh, df pd dot data frame 1, 2, 3, 4 and the column values. And the second data frame df2 pd dot data frame 5, 6, 7, 8 and the column values. So I tried to add like two things like df dot append df2, and that is the reason the output will be 0, 1, 2, 1, 3, 4, 0, 5, 6 and 178. So those are the individual data frames, but after appending, this is the output that I got. Reindexing. So if you want to reindex, you can do that. Uh, Here, if you want to reindex anything, we need to give the index particularly. If you don't want the reindexing, we can simply leave it so that it will get the initial index like 0, 1, 2. Here I mentioned 1, 2, 3 because I want my data to start at like 1. The index should start at 1. That is the reason I mentioned index equal to 1, 2, 3. So that is reindexing. And you can do the reindexing in the another way. For example, if you observe the code in the down part, I mentioned df dot reindex equal to 0, 1, 2, 3, 4. So I mentioned like whatever, like from where the index need to be start for my data frame. So we have that option. So this is the original data frame and this is the reindex data frame. So the original data frame, it starts at 1, 2, 3, and the reindexed, it starts 0, 1, 2, 3, 4. But as there are no values for the 0 and 4, that is the reason we are getting NaN. Cleaning the data. Let's see how to clean the data. Because in your EDA homework, you are going to clean the data. So by using this method. Missing values. See, if you observe this Excel sheet, there are some missing values. At the age, at the cabin, there are some missing values. How to handle missing values? As I said you before, if there are only 2 to 3 values in your entire column, those are missing, you can replace those values with the mean or median, like or mode. So those comes under the descriptive statistic. So with those values, you can simply replace the missing values. But if we already said, like if it is greater than 50%, we can remove the rows or the columns, because like most of the data is missing, so you can't simply replace all the values with the mean, right? So whenever your column is missing more than 50%, 60% data, just simply delete it. Okay. Next, duplicates. Yeah, if you have any 2 to 3 rows as same, those comes under the duplicates because they are waste. We can't, so we can't use them, like we can't keep the duplicates and we can't do the model building. Okay. So in order to remove the duplicates, we can use like df dot drop duplicates to remove the duplicates. So let's see what are the duplicates. So if you observe 7, 12, and 13 rows, those are same. Those are exactly same. So we need to remove it. And check data types and inconsistency. Not only missing values, null values, duplicates, you also need to check for data inconsistency. For example, like here, if you see the age, inconsistent format. So if you have a date column or any date of birth, like DOB column, for example, if there are like 10 rows saying that year, month, and date, and another rows saying that month, year, and date. So you can't deal with that column directly. So you need to use whether like two data frame and you need to apply that. And you can normalize the values by using str.lower or replace. Like if you want all your column names as lower values, you can apply those method like str.lower. So it will make all your column values as like lowercase letters. And spelling errors, you need to check for spelling errors. And you also need to check the data types. So this you are going to deal with one hot encoding. I know like most of the students are sleeping, but anyone know that one hot encoding? One hot encoding. One hot encoding. Basically, many students they used to skip. So where they will skip? For example, you got the data set, and like professor said, like to plot the correlation plot, like to draw the correlation plot. Correlation plots only deals with numerical values. You can't plot the correlation using the like the object data types or string. So what you will do? So there is only one column in your data that is like string data type or like non-numeric. So you will use one hot encoding and convert that to a numerical type, and then you can use it for correlation. So one hot encoding is basically useful to convert that categorical variables into some coding so that you can perform the correlation. Normalized text data. If you observe that str.strip, so it will make your columns removing the spaces between the values. For example, in your column, there are some spaces in each values. So those can be removed by using str.strip. And to convert the lowercase, you can use str.lower just to convert your like column values into lower. and check for irrelevant and redundant. Like these are the other stuff. Like you always make sure that the correlation matrix, whether you are doing with all the like int data types, and you need to check for the constant values, and you need to check for the meaningful information. Like for example, if there are nan, you need to check what I need to replace. And yeah, so this comes under the data accuracy. So for example, if you have a column that age is -1, the age can't be less than 0, right? So you need to check whether your data may contain this kind of values. And if you have, like for example, BMI, it is fixed. It always starts at 10 and it ends at 50. And IDs and also the foreign key relationships. So apart from cleaning the data, you always need to make sure that your information is correct. And scaling issues, starting we discussed the employee salaries with the board member salary, because there are like different values, but you need to keep all the values on the same scale. And if you have the imbalanced data, so you need to deal with the imbalanced data by using oversampling or like some sampling techniques. Multicollinearity, for example, uh, if you have a like housing data set and you are trying to predict the price of the house, so you will consider some variables such as like what is the location of the house, like how many years it has been done, the house construction, and next what is the rent and what is the demand for that place. So you will consider this type of like variables, and you will see the correlation between the price of the house and the variables that you consider. You can see that correlation by using the correlation plot. What is meant by multicollinearity? So multicollinearity means like your target variable is making like having the high correlation with two or three variables. So it comes under multicollinearity. And date to time format, you should make sure that they are in correct format. And one hot encoding, when you are going to deal with the categorical variables, you will use one hot encoding. And yes, that is the end for this, but one second, I will show the code. So this part, which we are going to discuss further, will be useful for your EDA homework. So just please concentrate. So clean data. So I loaded the data. This is the data frame that I got. See, if you observe this data frame, the species column, it comes under the categorical, right? Like these are all numerical, but this is not. So, and how to check the null values? By using isNull.sum. So isNull will check whether there are any null values in your columns. And the sum method, it will just count the number of null values in the each column. So if you observe, there are no null values. And duplicates, df.duplicates. So I check the duplicate values. There are no duplicates. And I just applied like drop duplicates if there are any. And data types. See, did you observe the data type of this species? It is object. So if you want to do the correlation and you want to include the species, what you need to do? You need to perform one hot encoding on the species, and next you need to use that in the correlation. This all comes under the int float, which can be done in the correlation. And str.strip, so it will remove any spaces that are in the species column, like this. And str.lower, it will convert all your column values into lower case. Okay. And see here, I I plotted the correlation, but if you observe that I dropped the column species. So why I dropped the column species? Because it comes under the object data type, and we can't plot the correlation for the object data types. So that is the reason I plotted the correlation plot. So this is how the correlation plot will look. And I plotted it by dropping the species column. And here, uh, This is the correlation plot. So if you observe, this is the correlation plot, and this is done with by dropping the species column because it is categorical. And in the correlation plot, so this will explain how much the two variables are correlated. This is the important concept. So the thing is, see, if you this is the one. So here, if you observe, the color is like it's very thick, and if you observe the line, like here, let us consider this the red part. So if you go down, it will the intensity is decreasing. So which explains that the variables having these values are highly correlated, and this will come somewhat like low correlation, and this very low correlation, and this is like very low correlation. So the correlation will get decreased from like step by step. So here, if you observe the petal width and the petal width, basically the two variables, the correlation will be one, but don't get confused. As we are considering the two variables, anyway, the correlation will be one. So you need to observe, if you observe that petal width and petal length, see the correlation is 0.9. In correlation, there are three types of correlation: positive, negative, and zero. So positive means like 1, and negative means -1, and zero correlation means 0. So based on that, based on these values, you need to check which variables are most related to your target variable. So these are all the values, and based on these values, you need to select which variables are there. 2 minutes, I will complete. So this is one hot encoding. Yeah, see, I performed one hot encoding on the species column. So that is the reason I can still include the species column in the correlation plot. So make sure when you are dealing with the object data type, you first perform one hot encoding and then you can use in the correlation plot. So just as an example, I displayed these two. This is without species. This is with species. So just please don't ignore it when you have object columns. You try to convert it into one hot encoding. I mean, you perform one hot encoding and you did the correlation. That's all, I think. And this is like applying the standardization and normalization. So this is the code that you will get, like even from ChatGPT. Okay, so this is done of data cleaning. I think I explained all the important concepts. So your EDA homework will be very easy. Just go to this code and you just observe the concepts and you just apply it on your home. Okay, done. So, okay, we are at 10:45 done. So now I will display the code for the attendance. Yeah, I'll do that. Okay. Stop recording.